Good morning, guys. Hope that you guys all had a good weekend and got to be outside a little bit and take a little break from your e-learning of school. I'm sorry that I didn't have your submission up right away yesterday for worksheet 6. So if you didn't submit worksheet 6 yesterday, make sure you submit that today. It won't be late. I had it up late. But I know that more of you than usual did not turn that in, so make sure that if you did it and just didn't submit it because the submission wasn't there, it is there now. And I'll check that in tomorrow night. It looked like most of you guys were doing pretty good on radicals. You can definitely use transformations when you do those graphs, so go ahead and feel free to do that. Today, you guys are going to be graphing rational functions, so I'm actually going to give you a little preview of the lesson so that you can hopefully have more success doing that. Alright guys, so when you're graphing rationals, these are the kind of graphs that are basically fractions. The first thing that you want to do is you want to factor. So I already factored the first one for you. Remember, setting the denominator equal to 0 is where you're going to have a vertical asymptote. So your vertical asymptote here is going to be at x equals -1. Now, horizontal asymptote is not just setting the top equal to 0, it's looking at the degrees. So since both of these have the same degree, they're both x to the first, we're going to use the ratio of their leading coefficients. So 1x on top and -2 on the bottom means our horizontal asymptote is going to be at -1/2. It's okay that it's a fraction. Okay, holes happen when you set something, when something canceled out, when you factored. So since we didn't factor or cancel anything out, we are not going to have a hole this time. The x-intercept is what you get when you set the top equal to 0. So when I set x minus 4 equal to 0, I get x equals 4. So my x-intercept is 4, 0. And then remember, these are the kind of graphs where you want one point on each side of your vertical asymptote. So if I do an XY chart, I'm going to put the vertical asymptote in the middle, and I'm going to choose a number on each side. So I'm going to choose -2 and 0 to plug in. I'll start with 0. So 0 minus 4 is -4, 0 minus 2 is -2, -4 divided by -2 is +2. Okay, and then if I plug in -2, -2 minus 4 over -2 times -2, minus 2, looks like I'm getting -6 over 4 minus 2, so that would be at -3. So if I put those 2 points on my graph, that's enough for me to now draw the branches of my hyperbola. So I've got one branch in this upper right-hand region and one branch in this lower left-hand region. Okay, and it's always that same shape of graph. You're definitely going to want to look back at the note sheet from day 9 or day 10, I believe. This was in chapter 3b. Remember, we had these step by step though. First, factor and cancel to see if there's any holes. Find the vertical asymptote by setting the denominator equal to 0. Here's your 3 cases for horizontal asymptotes. Find the y-intercept by setting x equal to 0. Find the x-intercept by setting the numerator equal to 0. I wouldn't worry too much about it intersecting the horizontal asymptote, but it could. Plot existing points, get more as needed. You need one on each side of the vertical asymptote, and then complete your sketch. So I just want to do one more preview problem where you actually have a hole. So number 2, if you factor the denominator, you would factor it to x minus 3, x minus 2. So remember that when you cancel something out, that's when you're going to have a hole. So the hole in this problem is going to happen, we set that eliminated factor equal to 0. So x minus 2 equals 0 gives us x equals 2. The hole happens at 2 comma something. How do we get the something? We plug it into this new equation. So 1 over 2 minus 3 gives me -1. So I'm going to put this on my graph right away so I don't forget that I have a hole at 2, -1. Everything else from this problem is done from this new equation, 1 over x minus 3. So vertical asymptote is going to be at x equals 3. Horizontal asymptote, because we have 0 x's on top, is y equals 0. And then we go from there. You will also have a couple that have oblique asymptotes, so just a quick reminder, you're going to do synthetic division or long division. So here's my synthetic division. 1 goes on the outside. The top numbers are from the numerator, and then you do y equals x minus 1. You ignore the remainder when you're doing your oblique asymptote.